Welcome to The Explainer. So, if you've ever wondered how humans and, well, animals too, actually acquire new skills, whether it's learning to ride a bike, mastering a new language, or even just figuring out how to use one of those incredibly complicated new espresso machines, you are in the exact right place. Today, we're exploring Thorndike's theory of connectionism. How do we actually learn from our mistakes? We all hear that failure is just part of the process, right? But what are the actual, literal psychological mechanics behind it? Okay, let's dive into this, because the answer lies in an absolutely unforgettable psychological experiment that pretty much changed how we view education forever. Section 1, the puzzle box experiment, or E.L. Thorndike's famous feline test. Thorndike is widely known as the father of modern educational psychology. But to figure out exactly how we learn, he didn't actually start with humans. No, he set up a rather high-stakes situation for a very hungry cat. Just imagine the scene playing out. Step 1. A hungry cat is placed inside a locked puzzle box, and a tantalizing piece of food is left just outside. Naturally, in step 2, the cat tries absolutely everything to get to that food. It swipes, it scratches, making all these random, tentative responses. But then, step 3 brings accidental success. The cat bumps the correct mechanism, the door swings open, and boom, it gets the food. Now, step 4 is where the real magic of learning happens. Thorndike found that on repeated trials, the time it takes the cat to escape decreases rapidly. Why? Well, because trial and error isn't just flailing around randomly. It's actually a highly systematic process of eliminating incorrect responses to establish the correct ones on each subsequent try. Section 2, the mind as a switchboard, understanding connectionism. Let's move to and see how this builds. We're going to zoom out from that wooden puzzle box to look at the underlying invisible mechanics happening right inside the brain of the learner. Thorndike proposed what we call connectionism. At its core, this is a stimulus response, or SR theory. It basically assumes that through conditioning, specific responses come to be permanently linked with specific stimuli. You see, Thorndike viewed learning as a highly mechanical process. Every single time a learner makes a mistake and then corrects it, they are quite literally forming physical bonds in the brain. The stimulus is the puzzle box, the response is pressing the correct lever. It's a direct physical link. Thorndike himself put it perfectly in this quote: "The mind operates like a telephone switchboard, selecting and connecting appropriate stimuli with appropriate responses." And this brilliantly illustrates how elegant this century-old analogy is, especially when you look at modern neuroscience. Picture an old-school telephone operator, physically plugging a wire into a socket to connect a call. Your brain is doing the exact same thing, routing hardwired connections between what you experience and how you react to it. Section 3. 3 primary learning laws, the trilogy of learning. We're now going to systematically break down the big 3 primary laws of learning that Thorndike derived directly from watching that clever cat plot its escape. This trilogy of learning consists of the law of readiness, the law of effect, and the law of exercise. These 3 laws form the absolute foundation of how habits, skills, and knowledge are acquired across the board. So let's unpack each one individually to see how they actually govern our everyday learning. First up is the law of readiness. This law states that if a child, or really any learner, is genuinely ready to learn, they learn more quickly, effectively, and with way greater satisfaction than when they're not ready. Basically, readiness is an essential prerequisite for action. Think back to our feline friend in the experiment. If you put a perfectly full, sleepy cat into that puzzle box, it wouldn't try to escape. It would just take a nap. The cat had to be genuinely hungry. That state of mind, that physical drive to act, that is readiness. Next, we have the law of effect. This dictates that learning takes place properly when it results in satisfaction or pleasure. For the cat, the food reward waiting outside the box provided immense satisfaction. Now, imagine if escaping the box resulted in getting sprayed with a bottle of water. I mean, the cat wouldn't be very likely to press that lever ever again, right? This emphasizes the absolutely critical role that rewards and punishments play in ensuring the effectiveness of learning. We mechanically repeat what feels good. The third law is the law of exercise. Now, what's really interesting about the slide is that it actually breaks down into 2 contrasting halves. On the left, we have the law of use. Making a connection between a situation and response actively increases its strength. This is where repetition, practice, and drill work come in. But on the right, we have the law of disuse. Failing to make that connection over a length of time decreases its strength. Basically, it's use it or lose it. If the cat isn't put in the box for a year, it might completely forget how the lever works.
Drill work strengthens those stimulus-response bonds, while a failure to exercise them causes decay.
Moving on to Section 4, Subordinate Laws of Learning, the 6 nuances of learning. Beyond the primary trilogy, Thorndike identified 6 more subtle nuances that affect how quickly and efficiently those mental switchboard connections are made, especially in more complex situations. Don't worry, we'll go through these quickly. Let's fast track through these nuances. Multiple response is simply trying different tactics, like our cat swiping and scratching randomly at first. Attitude means learning is heavily guided by your total mindset, or having a healthy attitude toward the task. Prepotency of elements involves using insight to select the most critical, prepotent elements of a problem. Then we have analogy, which is relying on past similar situations. Polarity, where connections simply act most easily in the direction they were first formed. And finally, associative shifting, which is adapting capable responses to completely new sensitive situations.
Section 5, Modern Educational Implications, Applying Thorndike Today. Let's pivot now from the theory to real-world application, because it is truly inspiring how a century-old experiment with a cat in a wooden box translates so perfectly into our modern daily life, our classrooms, and even our own self-improvement journeys.
Whether you're a teacher, a professional, or really just someone trying to learn a new hobby, these practical takeaways apply directly to you. You have to motivate learners, understand the absolute importance of readiness, strengthen bonds through drill work, value repetition, use past experience, and encourage independent work. So the crucial point is this: we can design vastly better self-guided learning by embracing these mechanical steps instead of fighting them.
So, what is your own puzzle box, and how will you use trial and error to escape it? Whether it's a complex coding problem at work, a tough negotiation, or learning to play an instrument, remember that every single mistake you make is just a necessary mechanical step toward the correct response. Embrace the errors, because they are quite literally building the switchboard of your future success. Keep practicing, keep forming those connections, and thank you for joining me on this explainer.